Hi there, this is Rick for Video Mobile again. Now we're going to look at arrays and tuples. This first function demonstrates arrays by returning one from a function. We have an array here declared, Fibonacci, an array of integers. Fibonacci series is a series in which one particular element is the sum of the previous two particular elements. This can be easily expressed in an array. Now, for those of you who are used to seeing Fibonacci functions or other functions implemented using recursion, we're not doing that right now. Yes, you can recurse in Swift. Now, if you don't know what I'm talking about, just ignore me for a couple of seconds. You can use recursion in Swift. Swift does not handle tail recursion very well. So if you know that your recursion is going to be less than several thousand elements, functions, thunks being pushed on the stack, then go ahead and do it. Otherwise, be very careful. Okay, back to the real world. Here we have a function called generate fibs. We've chosen count as a named parameter, an externally named parameter, because it's a good name, taking an int, returning an array of integers. And the idea is we're going to get a Fibonacci series into an array and return it and then assign it to our array out here called Fibonacci. Of course, we could complicate this by making Fibonacci a parameter into it and then using it as an in-out parameter and just get it all in there at once. But we'll leave it simple for now. So we've set up our output array, first of all, to be the array containing two integers, 1 and 1. This array is inferred, the type is inferred to be of int because 1 and 1 are ints by default. Now, Fibonacci series is defined to be 0 if count is 0. If the number of Fibonacci numbers that we want is 0, then we return 0. Actually, we would return an empty set, but this is okay. And then if count is 1, we return 1. Now, what we want is we already have the first two Fibonacci numbers. Each subsequent Fibonacci number is the sum of the previous two. So we set up an I counter called I, which is a 2. And then while I is less than count, we append the next Fibonacci number to the array and bump I, increment I. And then finally we're done. We return the output. So how do we call this? Well, here we're calling generate fibs count 0. This will give us back an array, or count 8. This will give us an array containing 8 elements, the first 8 numbers of a Fibonacci sequence. So we can print that array wholesale. We can print the entire array. So let's go ahead and run it to that point. And you can see that we've got it so far. We've got our Fibonacci series printed out as an array. 8 elements, 1, 1, 2, 3, 5, 8, 13, 21. All right. We can also iterate over that array using a for in loop. For fib in Fibonacci. What is type fib? Well, it's an int because Fibonacci is an array of ints. Fib's type is inferred by the type of the elements of the Fibonacci array. So we can do a print line fib here, and it will print downward 1, 1, 2, 3, 5, 8, and so forth. 13, 21. All right. What else can we do? We can print a particular element. We can get a particular element of the Fibonacci series. Fibonacci at 5 should be, remembering that arrays are 0-based, should be 8. And there it is. We can also use an arrange with arrays. Fibonacci from 3 to 5 gives us 3, 5, and 8. Let's take the sum of those three. For fib and Fibonacci 3, 4, 5, add them up and put them in sum. And 3 plus 5 is 8, and 8 is 16. So there we go, print line sum, and we get 16. So we're doing good. Now, let's look at tuples. That's just some of what we can do with arrays. The only thing I didn't discuss in the presentation was using a slice or using a range for the subscript of an array. But we can see how that works. You cannot specify, however, it's not really a slice. You can't specify Fibonacci 5 dot 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 3, because the first element in a range cannot be greater than the last element in a range. These are subscripts, they have to go in order. Alright, so let's talk about tuples a little bit. One of the things I said about tuples, the most important thing I probably uttered about tuples, is that we can return tuples from a function. So let's recode the swap function using tuples. Swap1 takes a tuple with two named parameters, or two named values, a as an int and b as an int, and it returns a tuple of type int. So let's look at how that works. And what are we doing here? Just for swapping, it's pretty easy. We return tuple b, tuple a. The tuple is two named ints, a and b. So we're returning tuple.b, tuple.a. And that swaps them. So now if we say some tuple is 1, 2, and print it out, and then swap their values, we'll get the swap values of some tuple. So let's see if that worked. Well, some tuple is 1, 2, and then we swap them and we get 2 and 1. So that works. These tuples have indices, and these are parameters, kind of a pseudo parameter. SumTuple.0 is the first element of a tuple. SumTuple.1 is the second element of a tuple, and we have 2, 3, 4, depending on how many values we have in the tuple, -1 will get you there. However, it's awfully nice to be able to use named parameters, and we're doing that in a function. So how would we rewrite the function to return the tuple with named parameters? Well, we'd kind of do it this way. Here's swap2. The tuple is still coming in as a and b, but we're returning a tuple with the first value named first and the second value named second. So we need to return first is tuple b, second is tuple a. So we're seeing how this is being done. And then we do swap tuple, or this swap2, using another tuple, 2, 3. We print it out, and then we say a tuple is swap2 with another tuple, a tuple first, a tuple second. We are getting back a tuple that has named values, first and second. Another tuple does not have named values, and that's why we can't assign another tuple to the return value of swap2, because another tuple is of type just int, whereas a tuple is of type first int, second int. So here we can get them back, and of course we do. Swapping 2, 3 goes 3, 2. Okay, so very powerful concept here. Arrays are marginally more important than tuples. Tuples become very important as return values from functions, which we shall see as we go through the course. Thank you very much.